Hey y'all, so in this video we are going to review what it is to be a linear function. So we want to be able to identify a linear function. A linear function creates a line when graphed. So this is your basic definition. Also, the standard form of a linear equation, you may remember, looks like this. Ax plus by equals c, where a, b, and c are numbers, and a and b are not both 0. What I want you to notice when it is written in standard form is that we have x and y both have exponents of 1, or we can't see it. That's part of our invisible math. But they don't have like a x squared or y squared. X and y are not being multiplied together. They're adding. And x and y do not appear in the denominator of a fraction. They are not in the exponent, and they are not under a radical or a square root symbol. So we don't have any of these fancy different symbols with our linear equations. In a linear function, a constant change in x corresponds to a constant change in y. This is our slope. This is how we recognize a linear function. So if we have some ordered pairs or a table, we can find out if it's a linear function by putting the ordered pairs in a table if it's not already in one. Then find the change in x and the change in y. We're looking for a pattern. If there is a constant change in x corresponding to a constant change in y, then it's linear. So let's take a look at our first example, looking at if it is linear. So again, we want to look at our change. So x goes from -2 to -1, 0, 1, 2. It's adding 1 each time. Then we look at y. 7 to 4 to 1 to -2, and so on. We're subtracting 3 each time. So in this table, a constant change of adding 1 in x corresponds to a constant change of minusing 3 in y. Therefore, these points satisfy a linear function. We can see that when they are graphed, these points lie on a line. In this example, again, we can see that x is increasing by 1. However, when we go to look at y, 6 to 3 to 2 to 3 to 6, there is no constant change. So in this table, a constant change of +1 in x does not correspond to any constant change in y. These points do not satisfy a linear function. And if we graph this example, the points do not lie on a line. So let's take a look at a set of ordered pairs. To tell whether the set of ordered pairs satisfies a linear function, we want to first write the ordered pairs in a table. So you can see the point 0, -3, we have 0 in x, -3 in y. 4, 0, 4 is in x, 0 is in y. Generally, we want to put these kind of in order. I like to put them in the order of x increasing, so 0, 4, 8, 12, 16. I can then easily see and look for the pattern, 0 to 4, 4 to 8, 8 to 12, that's increasing by 4. On the y side, -3 to 0 to 3 to 6, that's increasing by 3. So here we have a constant change of adding 4 in x, corresponding to a constant change of adding 3 in y. That's how I know that these points satisfy a linear function without needing to graph it. As the final part of this lesson, you try one more problem. See if you get, is it a linear function or is it not? And of course, the summary of our lesson. Linear equations create a line when they're graphed. When you're looking at tables or points, look for a pattern where a constant change in x is corresponding to a constant change in y. Also remember those 3 things from what a linear equation looks like.